In this video, we are going to work on problem 4.1.11 from the textbook. Consider the function given by f of x is x squared times sine of 1 over x plus cx if x is not 0 and 0 if x is equal to 0, where c is a constant that is greater than 0 and less than 1. And in the first part of the problem, we have to prove that f is differentiable on R. And in the second part of the problem, we are going to show that for any alpha greater than 0, the function f prime changes its sign on the interval minus alpha alpha. That means we can find some x in this interval such that f prime of x is greater than 0, and at the same time we can find some u in this interval such that f prime of u is less than 0. Now we are ready to solve the problem. For this function, we can easily show that it is differentiable at any x bar that is not 0. Okay, and now we are going to show that the function is differentiable at 0. Okay. Now we have the following. The limit of f of x minus f of 0 over x minus 0 as x approaches 0 is equal to the limit as x approaches 0 of f of x minus, as you can see, f of 0 is 0, so we replace f of 0 by 0 over x minus 0. So this is equal to the limit of f of x over x as x approaches 0. Okay. Note that if x is not 0, f of x is x squared times sine of 1 over x plus cx. So this limit is equal to the limit as x approaches 0 of x squared times sine 1 over x plus cx over x. Okay. This is equal to the limit as x approaches 0 of x times sine 1 over x plus c. Okay. When x approaches 0, we can easily prove by the squeeze theorem that this limit is 0. So by the sum rule, the given limit is equal to c. Okay. So by the definition of the derivative, f is differentiable at 0, and the derivative at 0 is equal to c. Okay, so to summarize, we can write the derivative of the function as follows. F prime of x is equal to 2x times sine of 1 over x minus cosine 1 over x plus c if x is not 0, and is equal to c if x is equal to 0. Okay, so this is the formula for the derivative function. Now, for the second part of the problem, recall the following formula for the derivative function. F prime of x is 2x times sine of 1 over x minus cosine of 1 over x plus c if x is not equal to 0, and f prime of x is equal to c if x is equal to 0. We are going to show that x is some x in the interval minus alpha alpha at which the derivative function is greater than 0. And at the same time, we can also find some u in the interval minus alpha alpha at which the derivative function is less than 0. Okay. Observe the following. F of 1 over 2 n by is equal to, actually f prime of 1 over 2 n by is equal to, the first part here is 0 because we have sine of 2 n by, and when we replace x by 1 over 2n pi, we get cosine of 2n pi, which is 1. So this is equal to minus 1 plus c. And because c is a number in between 0 and 1, this is less than 0. And f prime of 1 over pi plus 2n pi is equal to, we replace this number in here, and observe that sine of pi plus 2n pi is 0, so this pi is 0. Okay? And cosine of pi plus 2n pi is equal to minus 1. So this is equal to minus of minus 1, that is 1 plus c. So this is greater than 0 because c is a positive number. Okay. Now, given any alpha greater than 0, as you can see, as n approaches infinity, 1 over 2n pi approaches 0, and 1 over pi plus 2n pi also approaches 0. We can find some n naught in n such that both 1 over pi plus 2n pi and 1 over 2n pi, 2n naught pi, is greater than minus alpha and less than alpha. Okay. So, so you can see that the derivative function at 1 over pi plus 2 n naught pi is greater than 0, and the derivative function at 1 over 2n naught pi is less than 0. Therefore, the derivative function changes its sign on the interval minus alpha